In this lesson, you will review how to solve systems of equations using the substitution method. Last year, you learned how to solve systems of equations using substitution, elimination, and graphing. Substitution is the method out of the three that you'll use most often in geometry. Once you hit Algebra 2, you'll use all three of the methods again. For now, quick recap of what a system of equations is. It's a group of equations that have the same solution, and you often see them marked with a bracket symbol on the side to tell you the equations are grouped together. Now, if you want to use substitution to solve a system, step one is to look for a variable by itself on one side of an equal sign. So you're looking for an equation that starts with either x equals or y equals. In this problem, we have an x equals equation, x equals y plus 9. Circle the x. And then, in the second equation, circle the same variable. The idea of substitution method is that if we know that x really equals y plus 9, we know that the x in the second equation really equals y plus 9 as well, so we could substitute in or replace the x in the second equation with what x really equals, y plus 9. We're just plugging in the y plus 9 equation where x used to be. Go ahead and solve for y using this equation. Don't forget to start by distributing. So after you distribute, you want to possibly draw a line under the equal sign to remind yourself that if you have like terms on the same side of the equal sign, you should hunt them down and combine them. Here we've got a 3y and a 5y both on the left side of the equal sign. So it's probably helpful to write them next to each other first and then add those like terms. So to solve for y, you'd have to cancel out the plus 27 first, so you minus 27 from both sides, and then divide both sides by 8. You should get y equals -1. Now, one key thing to remember about systems of equations is that because there's two different variables involved in your original system, you need an answer for both variables. So we have our answer for y, but we still need our answer for x. But that part's relatively easy because you just take your equation for x equals y plus 9, and you say, well, now I really know that y equals -1. I could plug in -1 where y used to be. X equals 8. Question 2. What's the one variable that you could see by itself on one side of an equal sign? Circle it. You've got a y equals by itself. So we're going to hunt down the other y in our system of equations and circle that as well. So if y really equals 3x plus 11, we can plug in or substitute 3x plus 11 for y in the other equation. So now instead of minus 2y, it's minus 2 parentheses 3x plus 11. A quick note, you're going to start with distributing again, but notice how this time when you're distributing, it's not just the 2, it's the sign in front of the 2. You're distributing a -2 to everything. So -2 times 3x is -6, -2 times 11 is -22. Now you can add your like terms and solve for x. Finish the problem. For x minus 6x becomes -2x, and then you can work to get x by itself. Cancel out the -22 by adding 22 to both sides, and then dividing both sides by -2 to get x all the way by itself. We know what x equals. Go ahead and solve for y. When you plug in our answer for x, you should get y equals negative 49. Question 3. For this problem, which variable would you circle because it's by itself? So we can plug in for x in the second equation. Go ahead and finish solving for y. This time you don't really have a long equation plugged in, so you're not distributing, you're just doing 7 times 2y. And then you've got like terms, 14y minus 4y is 10y, so y must equal 3. Solve for x. What do you get for x? When you plug in the fact that y really equals 3, you get x equals 6. Well done, everybody.